All right, so the name of your properties thing says properties of polygons, but I changed it when I started the unit because I realized there are no polygons in here. They're all four-sided, except for those three-sided triangles, and they weren't in this packet. So I changed it to quadrilaterals, and I threw this in as an illustration of what all do you know about quadrilaterals. Well, you know that parallelograms have two sets of parallel sides, right? Don't rectangles, rhombuses, and squares all have two sets of parallel sides? Yeah, but they have some special relationships. Like, for example, every square is a rectangle because it has four right angles, but not every rectangle is a square because every rectangle doesn't have four equal sides. Or a kite. Did you know that's why they call it a kite? It's not because somebody named the thing you fly in the air a kite, and then they decided, oh, that's going to be a geometry shape. It's because it was a geometry shape, and they made the kite that shape. And there's a right kite versus one that's not a right angle. And the right angle could be up here at the top. You can see that's a right angle or not. And then trapezoid, there are three here because I wanted you to realize trapezoids don't have to be equal on each side, but when they are, they're isosceles trapezoids. And if it has two right angles in it, it's called a right trapezoid. You're more familiar with these two, probably not as familiar with the one with the two right angles. So these are all the different quadrilaterals. So we're going to focus on one or two of these a day. Okay? Today we're going to focus on parallelograms. So parallelograms are quadrilaterals that have two pairs of opposite sides parallel. It says mark the parallel sides of the parallelogram A, B, C, D. Well, what symbol do we use to say something's parallel? What? Huh? Anybody remember? An arrow. Sometimes the arrows are just drawn like that. Sometimes they color it in like this. Whether you color in your arrow or you just make a greater than, less than symbol looking thing, it's an arrow. If you want to show these are, you put two arrows. So has everybody opened up the packet that says properties and turn to the first page and mark your first picture of this? So these are how you can mark that sides are parallel. Is you use little arrows showing which way the lines are going. Notice I did them differently because I wanted to say what was parallel and what was not parallel. So again, these are parallel line symbols. You draw arrows to show things are parallel, and you can color the arrow in, or you can just leave it like a greater than or less than. And since we had two sets of parallel sides, I used two arrows on the ones that were going a different direction. So please draw this on your notes. We are in the unit packet that says properties of polygons. And we're on the back of the first page. And that's all we've got done so far on the notes packet. Are we good? All right. So in the next page, we're going to mark our picture in a different way. Each page we're marking different things. And first thing you need to do is take out the green drawer and use number 15 to draw yourself a small parallelogram up here wherever you can get it. Maybe right under where it says your conjecture. Draw. Because yours is designed just a little bit differently. I moved mine around to be able to better space mine. So right where it's next to that box that says draw a picture to illustrate your conjecture, take number 15 and draw in a parallelogram off of the drawer. So the question is, opposite sides on a parallelogram are? Well, as you draw around that parallelogram, what do you notice about the top and bottom? They're parallel. Well, that we said in the first statement, so name something different. Not only are they parallel, but what else? They're equal. Okay. So the top is congruent to the bottom, and the left side is congruent to the right side, so we can say congruent. It means the same thing as equal, except in geometry words, they like to say things are congruent. The measure might be equal, but their letters like AB is congruent to CD, that type of thing. Alright, so those are congruent marks. You put little hashtags on there. The number of hashtags has to match. That's why I put 1 on top and bottom and 2 on the sides. They look congruent, right? Everybody agree? So, in these questions, it shouldn't be too hard to answer. Number 1, I wonder what X is. 23, because the top's 23. I wonder what Y is. That's right, it's 15, because the left and the right have to be equal, the top and the bottom have to be equal. Then sometimes they'll give you expressions, like in example number 2, they give you expressions. So if the top and the bottom are equal, you should be able to set them equal and solve for X. Obviously X is 10. And you can set the left and the right equal, and Y will be 8. Then they can get a little bit more complicated, like number 3, where you have expressions for both, but it's the top and the bottom, so I guess they're equal, right? So 12x minus 3 equals 8x plus 5 is not hard to solve. Why did I put 12x minus 3 first? Why did I put 8x minus 5 plus 5? That's right, I wanted the one with the biggest x's on the left. So if I minus 8x, how many x's will I have? 4. And at the same time, you can add the 3 to the other side if you want to, or you can do it as a separate step. I like doing it at the same time. So that makes it 8, and that makes x 2. Read the directions. Is that all I'm supposed to be doing? That's right. I got to go back and plug it in. So 8 times 2 plus 5 is 21. Because that's 16 plus 5. So make sure you read the directions, because you might just be finding a little more than that. All right, y'all playing with the compasses and you're not paying attention to what you're supposed to be doing. All right, draw another one next to the next conjecture box. Draw another parallelogram with number 15. And we're going to talk about opposite angles. Because obviously there are 4 angles inside of a parallelogram. And since my parallelogram isn't a special one, it's just the generic one, I have 2 acute and 2 obtuse angles. Would everybody agree with that? Well, when you talk about angles being opposite each other, like looking at this one down here, what letter's opposite A? Oh, so they're across from each other. So this obtuse angle is congruent to this obtuse angle. And the 2 angles that are acute would need 2 hash arc marks to show they're congruent to each other. And so we know they're congruent because they look the same. So the ones that are across from each other look the same size, meaning they're the same answer. So X has to be 110 because it's across from 110. Everybody agree? And Y is across from 70. Everybody agree? Y has to be 70. See how easy that is? Not only that, what do you notice about Y and X? Ooh. What about the top? 180. Side, 180. Bottom, 180. All the way around. All right. So in this problem, I have 120 obtuse, and 5x doesn't look obtuse. I don't think they look equal. So 5x plus 120 has to be 180. Well, we already know 5x is going to be 60, right? How do we know that? Because if 120 has to add up to 180, don't I need 60 more? Okay. So 5x is equal to 60. I could have figured that out without setting it up with 180 because that's what makes that angle. So x is equal to 12. The question said find x and find d. Well, I already know d is 60 because that's what makes those two make 180. And I know that x is 12 because 5 into 60, 5 into 60 goes 12 times. So I could find d first or I could find x first. It didn't really matter which one I did. But down here at the bottom it does, because in example number 6, they want you to find x and y and find c and d. And when I start looking at that, I can either use the equal to rule for opposite angles, or I can use the 180 rule, because don't these two make 180? But doesn't 55 and 3y plus 7 both make them equal? So I could go either way. It doesn't matter which way you solve it. I think I'll just go the equal way. So I know that D is 55. How do I know that? Because they're equal. They're opposite angles. But I've got to solve for y, so 3y equals 48, y equals 16. I can do the same thing for the equal angles the other way. I know that C is 125 because it has to be equal to angle A. But I can set up the equations of being equal to each other, add 5 to the other side and get 130, and divide by 13 and get 10. So I didn't have to find C and D after I found X and Y, because I know they're equal already. Does that make sense? And I could have done the 180 rule if I'd wanted to. I just thought the numbers were smaller without it. Use equal to angles whenever you can, y'all. All right, conjecture 3, draw another parallelogram. And on this parallelogram, we're going to actually put some letters. Because we want to write a couple of statements under the picture. And to write a couple of statements under the pictures, we need letters. But we're also going to put some marks on here also. All right. So, consecutive angles. Does anybody remember what consecutive angles from Math 2 meant?
Ain't they the same? Or
Well, yeah, they're next to each other. That's what consecutive means. Two things side by side. So, for example, this angle is consecutive with this corner because they're together on the same side of the picture. Does that make sense? Consecutive angles are supplementary. Because the measure of angle A plus the measure of angle D has got to be 180, because one of them's acute and one of them's obtuse. Now, label a lot more of them, but is one example that enough for y'all? Because I could put A and B together, I could put B and C together, I could put C and D together. As long as it's two off the same line, it didn't matter which side I went with. So I just chose to do the two on the left. But they're supplementary, they make 180, which we've already discussed in the previous slide, because they're either equal or they make 180. So if angle A in example 7 is 115, who else is 115? C. And if they're 115, then the other two have to be equal to each other and have to be how much? That's right, 180 minus 115 is 65. So D is 65. And B is 65. It's that simple. If you find the equal ones and you find the ones that are up to 180, you got it covered. So for example here, this is 40. How much is C? 140. Find that first. Instead of adding them together and setting it up for 180, just figure out what the other angle is and set it equal to what you've got. Then that'll make it 12x equals 144 when you add the 4, and x will be 12 because 12 times 12 is 144. Now, did I cover it? Did I find x? Yes. Did I find c? Yes, because 140 is c. So I found both of them. So down here, do I have any angles to go on? No. So is this where I've got to know if they're equal or 180? Absolutely. Which is it? 180. Well, how about we add like terms first? How much does that add up to? 16x plus 4. So that's what we're going to set 180 equal to. So if I take 4 away, I get 176. Y'all remember that rule I told you, when the two on the outside add up to the middle, it must be divisible by 11. Because if you add 1 and 6 together, it makes 7. Now, is that what they asked for? No, they asked for plugging 11 back in. So 11 times 11 minus 1 is 120, because that's 121 minus 1. So that makes this one 60. Well, 5 times 11 is 55, plus 5 is 60.
Sorry for the interruption. There will be no JV basketball games today. All teams will practice from 3 to 5. Again, no JV basketball games. Also, I need the following students to go see Miss Tatum at this time: Addie Bryant, Allie Amos, Brenda Chavez, Alec and Autumn Knight, Cheyenne Pretty, Finn Long, Lauren Collins, Sierra Hubbard, and Brendan Thomas. Thank you.
All right, I have 2 major concepts left to go on this lesson. I'm hoping we can get them done. Diagonals. They put both diagonals in. Does the diagonal from A to C look like it's the same length as B to D? I don't think they are. Let's see. If I draw this line, and then I rotate that line, is it the same? No. But there is a relationship. What is the same? Each half. Each half is the same. In other words, diagonals of a parallelogram bisect each other. Bisecting meaning that it puts it in the middle. Like if I put a letter here at E, E would be the midpoint of each segment, making each half of the diagonal equal to each other. So for example, if this is 8 from A to E, then from E to C has to be 8. Does everybody see what I'm saying now? The 2 halves have to be equal. Or I could have asked for A to C is 16 long. All right, over here, from E to B is 12. From D to E is 3x. Well, 3 times what makes 12? Okay, that was easy. All right. From B to E is 7x plus 2, and from E to B is 9x plus 6. I guess we set them equal? Oh, thank you. So if I have 9x minus 6 equals 7x plus 2, I can take away 7x. I can add 6. That's going to make 2x equals 8 and x equals 4. Is all they wanted to know x? No. They'd like to know what the whole line is. So if we put 4 in, for example, right here, 7 times 4 plus 2 is 30. But that's only from here to here. So how much is BD? 60. Or I could have added like terms and then plug the x in. And that would work also. You can work on half of it and double it, or you can add the like terms and plug in x. It works either way. So for example, over here, from here to here is 3x minus 8, but the whole entire line is 4x plus 6. Now how am I going to do that? I don't have what that one is. Well, these two add up to the whole thing, right? Isn't that one also 3x minus 8? Oh, 3x minus 8. So that's 6x minus 16 equals 4x plus 6. You can take 4x away. You can add 16. That's 2x equals 22, or x equals 11. Now, that didn't find AC, that just found x. So now let's go back and plug in 11. That's 50. Or I could have plugged it in here for x. Now, I'm going to run out of time on this last little piece, y'all. So I'm going to stop because I know that I don't have time. But I tell you what I'm going to do. So last but not least, what do the diagonals of a parallelogram do? Well, if you look at the example on 14, and you look at 35, and you look at x, don't they look equal? Well, what kind of angles are those? Well, let's talk about that. If you extend these two lines out to make them really into lines, then this diagonal would be called a transversal. A transversal is a line that cuts a parallel line so that it makes special kinds of angles. And these are alternate interior angles because they're alternating between the diagonal line, and they're interior angles because they're between the parallel. And they look equal, so they're congruent. Once you figure out that alternate interior angles are congruent, you can use all the rules that you have learned about shapes. For example, 62 would be the same as, oh yes, x, 62. Now, obviously I don't have an angle that alternates with y, but there's nothing there, so I can't use that to find y, because they didn't want it to be that simple. But I do know that these three are in a triangle. So y plus 100 plus 62 is equal to 180. Now we can take 100 away from 180 and get 80. And then 62 from 80 will leave us with 18. Now I put degree marks on these, where some of them earlier when I was solving for x and y I didn't. And that's because these x's and y's stand for the whole entire corner in terms of the angle. Unlike if we go back a couple of pages, like here, x was just part of the measurement of a side, or even these. X didn't represent C, it represented what goes in for 12x minus 4. So put degree marks when it stands for the whole entire angle. And that's all of this lesson, and now you can do the 401 worksheet, which is 3 pages. It has 10 questions.